climate change, biodiversity loss, urbanization, pandemics. These phenomena have a major impact on society and the environment and introduce significant uncertainty and complexity into policy and decision processes. Socio-environmental systems researchers and practitioners are increasingly concerned about potential long-term impacts of near-term decisions. To provide the most effective decision support, we need to critically and systematically expand our understanding of the future in socio-environmental systems.
Welcome to Creating Socio-Environmental Scenarios, a tutorial that is part of the Socio-Environmental Modeling series, devoted to the use of modeling to investigate complex problems at the human-nature interface. I'm Hanna Kosow, a social scientist at the Center for Interdisciplinary Risk and Innovation Studies at the University of Stuttgart. My research focuses on environmental scenarios and qualitative systems analysis. I also study the participation of experts, stakeholders, and citizens in research processes.
And I'm Vanessa Schweizer, an associate professor in knowledge integration at the University of Waterloo in Canada. I'm also the director of the Waterloo Institute for Complexity and Innovation. My research focuses on cross-disciplinary knowledge integration and the design of scenarios for the human dimensions of large-scale environmental change. This tutorial is based on an article that we co-authored with colleagues published in the journal Science of the Total Environment in 2020. The article grew out of a workshop at the International Congress of the Environmental Modeling and Software Society, where practitioners and researchers discussed the state of the art on the development and use of scenario analysis for exploring and understanding socio-environmental systems. In this tutorial, we provide an overview of how to create socio-environmental scenarios. Often, researchers focus heavily on scenarios as products, creating useful things such as projections, forecasts, and simulations. A separate CSync tutorial on futures thinking provides an overview of different kinds of scenario products. This webinar, however, focuses on the processes needed to make and communicate scenario products for effective decision support. Increasingly, for scenario products to live up to their potential, target audiences or users must buy into them, and scientific credibility alone may not ensure buy-in. Let's get started by specifying what we mean by scenario. In socio-environmental research, a scenario is more than a projection within some confidence interval. Scenarios are plausible bundles of simultaneous social and environmental conditions, and scenarios are most useful as a set. Scenarios are commonly applied in climate change research, for example, because climate impacts are not simply a function of hazards, such as extreme weather events. Climate impacts are the product of hazards and vulnerable conditions for some population that happen simultaneously. Scenarios refer to different bundles of conditions, such as heavy precipitation combined with poorly performing stormwater management systems, whereas a different scenario would be moderate precipitation combined with state-of-the-art stormwater management. So how might you develop and apply scenarios in your socio-environmental research? To help you articulate your research design for any particular study using scenarios, this webinar will provide an overview of the scenario lifecycle or scenario creation process for issues to consider before scenarios are created, during their creation, and afterward. Hannah will tell you what issues to consider before you create your scenarios.
Yes, but first, let me provide you with a big picture to help orient you to the rest of the tutorial. The three phases require a focus on different issues, ranging from the before phase, when you must think carefully about the purpose of the scenario modeling, to the after phase, when you must consider your audience and how best to communicate the scenario findings and evaluate their impact. The in-between or during phase is when many challenges have to be overcome. These span social and epistemological issues, as well as imaginative and technical issues. For this reason, we devote much of the tutorial to the during phase. Now, to start with the first phase. This before stage is when a great deal of work needs to go into scoping and designing, and it all begins by thinking carefully about the intended purpose of the scenario exercise. I'll describe a few, but keep in mind that socio-environmental scenarios can serve multiple purposes. Scenarios can be created for exploring and analyzing a socio-environmental system or problem. In so doing, they go beyond statistical forecasting and beyond developing most likely and most probable scenarios. Instead, they ask, what are possible future developments of the system under study? In this case, we develop exploratory scenarios that tell us what could happen. Socio-environmental scenario exercises also serve decision-making, planning, and preparing. Where do we want to go, and what do we need to do to get there? In this case, we create normative scenarios that depict pathways toward what we want to happen. Another purpose is communicating. In this case, scenarios stimulate discussion on possible or desirable futures. And finally, scenario exercises are used for teaching and learning. In this case, exploring possible or desired long-term scenarios can help educate about the complex dynamics of socio-environmental systems. Some of these goals are more substantial, where the actual content of the scenarios is central, while other goals are more procedural, where the learning and sense-making that occurs through the process of developing the scenarios is prioritized. Typically, scenario processes have more than one goal. Scientific purposes, policy advice, and communication often overlap in one scenario process, or more precisely, have a different significance during the different stages. As a consequence, most socio-environmental scenarios are directed at more than one audience, including, for example, the scientific community, policymakers, or the interested public at large. It is essential to be explicit about the purposes and audiences before developing scenarios, because this has consequences on the scenario process design. It has consequences for the data you will need to integrate and the type of data you would like to generate, and on data presentation and publication. Finally, your purpose indicates what methods to choose, for example, rather quantitative or also qualitative techniques. Considering the purpose carefully means you will need to address several key questions, including who to involve into the process beyond the so-called scenario core team. This might be colleagues from different scientific disciplines, diverse stakeholders, or even decision makers and citizens. When to involve these people, before, during, or after scenario creation, and how to involve them. Given that short overview of the before planning process, I want to move on to the creation phase, during, that is the generation and selection of scenarios. What is involved here? It's worth noting that during this phase, there are many challenges that are quite similar to those in the series by Sondos El-Sava titled Understanding the Grand Challenges of Modeling Socio-Environmental Systems. I'll highlight a few of those that are either particularly relevant or specific to socio-environmental scenario exercises. First, a central issue during scenario creation is how to work with multiple, diverse participants. During the construction of socio-environmental scenarios, diverse groups of actors and stakeholders are often brought together to include diverse perspectives, to create comprehensive system understandings, and to support learning and ownership. Therefore, scenario workshop facilitation is key. Facilitators need to carefully moderate conversations to avoid dominance by some. It is recommended to elicit and document every participant's view before integrating it into any consensual group judgment. Facilitators need to balance different perspectives and positions, and also need to support their integration. This requires a considerable level of experience, of domain knowledge, and of method expertise. The scenario core team needs to collect, compile, and integrate the generated information into useful scenarios, and at the same time assure a fair and inclusive process. This requires a considerable level of analytical and communicative skill. Various methods for consensus building and group decision-making are available to support these tasks. These include, for example, the Delphi method, group Delphi methods, multi-criteria analysis, and various other approaches to stakeholder and public engagement or participatory modeling. Finally, it is important to clarify roles and responsibilities among the different parties involved in scenario processes and to manage expectations. Otherwise, participants might be disappointed about the effective role they play or about the later impact of the scenario process. Uncertainties are a very relevant issue. We know that scenarios are used as a tool to deal with future uncertainty in socio-environmental systems. But how do socio-environmental scenarios deal with multiple types of uncertainty in scenario construction? Authors distinguish between three natures of uncertainty. First, there are epistemic uncertainties. These refer to the imperfections of our knowledge and may be reduced by further research. Epistemic uncertainties do manifest as lack of data or information, as parametric uncertainty, or also in the form of competing theories and models. Ontological uncertainties are due to the inherent variability in human and natural systems. More research may not reduce these. Regarding scenarios, the fundamental ontological uncertainty is related to the openness of future evolution of systems. This future evolution can be classified somewhere between deterministic and chaotic, involving in particular long-term scenarios, surprises, and unknown unknowns. We will come back to that. Finally, there are ambiguities. Ambiguity refers to the simultaneous presence of multiple frames in pluralist societies to understand and interpret the phenomenon of interest. In scenarios, these are, for example, different worldviews and preferences in the evaluation of future scenarios. In modeling, global sensitivity analysis is widely applied to systematically evaluate the effect of individual parameters on the model's results and to identify key uncertainties. Still, sensitivity analysis is limited to what is covered by the models. In scenario analysis, it is key to reveal and characterize the different levels of uncertainties that we encounter, and to make them explicit, to measure them, if this is possible and required, and to actively use them to ask the relevant and interesting questions. Another issue is how to combine multiple methods and multiple forms of knowledge. Socio-environmental scenario processes often require hybrid methodologies that involve using both quantitative and qualitative methods and data types. Hybrid methodologies often require integrating multiple sources of knowledge. These include scientific knowledge, stakeholder and local perspectives, as well as creativity. In particular, combining qualitative scenarios, sometimes also called storylines or narratives, with numerical modeling is an established and recommended approach. The most well-known approach is story and simulation, which combines storyline creation with numerical modeling. Typically, numerical models are used to represent environmental systems and storylines to represent social systems' future developments. These two parts are coupled through an iterative process. Another nice example of the use of hybrid approaches comes from work by Schneider and Rist, who combined exploratory systems modeling with normative and participatory scenario construction. This allowed to develop systems knowledge and target knowledge, as well as transformation knowledge on measures to transform the current system into the desired one. Hybrid approaches have a lot of appeal, but also raise considerable challenges, as they need to bridge epistemological and methodological gaps. Very concretely, for combining qualitative scenarios and quantitative modeling, translation methods are required to translate qualitative data, such as drawings or words, into quantitative data, numbers, and also vice versa. What does, for instance, moderate population growth mean in numbers? There are many methods for converting qualitative to quantitative data, or actually combining qualitative and quantitative data into a single analysis. As to translation, the most widely used approaches are rather intuitive and based on interpretation, ad hoc judgments, for example, when modelers themselves translate scenario narratives into information that is usable by their models. But many people have thought about how to overcome this practice of educated guesses and have tried out a variety of more scientific approaches to these challenges, namely more transparent and reproducible ones. These include, for example, systematic expert elicitation or fuzzy cognitive mapping. For detailed information, see the article by Malampalli and colleagues, in which they give a comprehensive overview, description, and assessment of 10 approaches, as well as guidance on when to use what approach. Thus far, we have seen how during scenario creation, we work with multiple diverse participants, and how we combine and translate qualitative and quantitative elements. Now let's shift to two issues that are essential to assure scenario quality, namely diversity and consistency. We'll start with diversity. A challenge that is specific to scenario modeling is how to assure diversity of scenarios. In the context of scenarios, to ensure diversity means that in a group of alternative scenarios, each should be as different from each other as possible. Why is diversity important? Scenarios are meant to represent possible future developments of a system under study. Since a set of scenarios is often used to test the robustness of strategies under different alternative context developments, a maximally diverse set allows us to see whether a strategy or policy works reasonably well under very different future conditions. In this paper, Bernstein and Trutnevite discuss current methods to address scenario diversity. To give one example, Henrik Carlsen and colleagues have pointed out that scenarios are often chosen arbitrarily to include conservative and extreme potential development. They developed a methodology for generating scenarios which are mathematically maximally diverse. That means they fill a broad diversity space. Their scenario diversity analysis method nicely addresses the problem of broad versus conservative scenarios and how to balance these. Other methods have been developed for ensuring diversity, and references for many of these are linked to the video. Let's now move from scenario diversity to another important aspect of developing scenarios, namely the need for consistency. Consistency is understood as a safeguard against what can be perceived as arbitrariness of scenarios. It is a criterion of the internal quality of a scenario that helps to justify why a scenario is composed as it is and why creators chose to focus on certain scenarios but not on others. Consistency refers to different issues, including a scenario's internal consistency, that means its freedom from internal contradiction, agreement between qualitative and quantitative parts of the scenario, and consistency across scales. Why is consistency important? The internal consistency of scenarios primarily is a concern for qualitative scenarios or storylines. These are composed of information and assumptions about how the different elements of the scenario, often called drivers, variables, or descriptors, will play out in the future. Examples are demographic change, value systems, individual behaviors, economic, political, and technological change. These assumptions cannot be freely combined. Instead, their interactions need to be considered to understand their logics and to avoid contradictions. For example, the Health in Harmony project uncovered a key driver of deforestation in Borneo, the cost of healthcare to low-income households. Due to a lack of local infrastructure, health crises would push households to deforest to temporarily raise funds to travel to a faraway hospital. Such driver interrelationships produced an internally consistent but vicious cycle of environmentally and economically unsustainable forest harvesting. Health in Harmony intervened in this scenario to break the vicious internal consistency by establishing affordable local healthcare. Once this driver relationship changed, households participating in deforestation decreased by nearly 90%, thereby transitioning outcomes on the ground. Still, consistency is not always attended to sufficiently, even in prominent publications. See, for example, the paper by Vanessa and Elmar Kriegler on the storylines associated with the IPCC Special Report on Emission Scenarios. We emphasize that for qualitative scenarios, internal consistency is very important. Missing it can hinder credibility, usefulness, and in the end, impact of qualitative scenarios. Luckily, Foresight provides several formalized approaches as alternatives to intuitive qualitative scenario construction and for consistency checks. I'll just mention two, namely consistency analysis and cross-impact balance analysis, CIB. Both are forms of qualitative systems analysis that consider interrelations between scenario elements pairwise. Consistency analysis assesses the plausibility of two developments to occur jointly. CIB assesses mutual impacts between alternative developments in a directed way. The context scenario approach using CIB proposes a hybrid methodology uniting qualitative scenario elements with a systematic modeling approach, and thus is a more formalized alternative to story and simulation. We also provide a list of additional resources at the end of this tutorial. Regarding consistency between different geographic and temporal scales, Vanessa, I'd like to hand over to you.
Thanks, Hannah. As straightforward as the concept of consistency might sound, work is ongoing to improve the internal consistency of scenario analyses that bridge different geographic and temporal scales. For such large-scale problems, it is common for teams of multidisciplinary researchers to contribute their expertise to provide partial insights. However, the challenge in these contexts is how to synthesize scenario data and/or processes across scales and research teams so that the different scenario analyses together provide coherent, informative findings about large-scale environmental change. Let's consider first some temporal differences that might need to be bridged. Natural processes in the ecological context have their own time horizons that might be seasonal or phenological. Meanwhile, processes in the social context also have their own time horizons that might be very rapid, for example, emergency response under a news cycle, or compared to relevant ecological processes, might be very slow, such as an election that might be years away. Setting aside these examples of temporal differences that can be difficult to bridge in scenario analysis, research teams might also conceptualize time differently. Alternative futures may be interpreted as describing alternative endpoints at some specified point in the future, for example, the world in 2050. Alternatively, futures might be pathways, that is, a series of sequential choices. Such viewpoints on futures, as endpoints versus pathways, also have implications for what time means. Many scientific studies conceptualize time as a time series, where alternative outcomes can be projected at specified time steps. However, risk analyses might conceptualize salient socio-environmental times as events or sets of system conditions, which are outcomes devoid of temporal markers such as years. Later, we'll return to the concept of scenarios as events when we discuss surprises in socio-environmental scenario analysis. Now that we have reviewed some temporal considerations, let's consider geographical differences next. Given the variety of ways that time and space might be conceptualized and modeled by different research teams, is synthesis hopeless if research teams were unable to align their research processes ahead of time? Not necessarily. Current guidance on linking scenarios across scales, whether geographical or temporal, follows norms established during the Millennium Ecosystem Assessment. In their 2007 paper, Zurich and Henrichs introduced a typology and spectrum of approaches to linking scenario analyses across scales. They explained that cross-scale linking can be achieved in two ways. First, through the manner in which scenario studies are built or process data, and second, through what scenario elements are shared. The approach with the highest internal consistency across scales would be a joint process between research teams with scenario elements quantitatively downscaled, which means that scenario elements are equivalent across scales. However, such levels of coordination and data availability are rare. More often, large-scale environmental change is studied by research teams working in parallel or independently, and quantitative downscaling is limited. An active area of research is how to preserve internal consistency, but also policy relevance across scales when some or most scenario elements are not quantitatively downscaled. Zurich and Henrichs suggested a spectrum of strategies that progressively relax what data and assumptions are shared across scales. According to their typology, more internal consistency across scales is preserved when boundary conditions between scales are fixed. This means that higher level or large scale scenarios provide strict boundary conditions for lower level or local scale scenarios. Another strategy is to apply the same scenario logics across scales. For example, if the global economy is committed to growth and conventional development, continental or country level priorities could reflect the same commitments. Importantly, however, Zurich and Henrichs recognize that imposing such uniformity across scales may not appear realistic to decision makers. Thankfully, there is ongoing methodological research on developments in consistency measures for scenarios that could be used to guide cross-scale scenario development. Using consistency measures provided by the method of cross-impact balances, realistic variations in outcomes across scales can be explored. Particular cross-scale outcomes, some that co-vary and some that do not, can be shown to be plausible based on the internal consistency of systemic influences across scales. Let's now turn attention to a perennial question in scenario analysis: whether and how to account for surprises. One might wonder whether it is an oxymoron to anticipate surprise. Let's consider then what surprise means and what approaches there are to account for them. A standard dictionary definition of surprise is an unexpected or astonishing event. Indeed, scenario analysts have classified some major families of surprise. These categories provide clues for how we might account for them in scenario analysis. First, there are wildcards. Similar to the colloquial meaning in a game, a wildcard is a scenario factor with a highly uncertain influence. The sources of its uncertainty might include that it is unprecedented, such as a new technology. Additionally, it might have the potential to have either desirable or undesirable effects, and it is too early to say what effects might become dominant. Contemporary interest in developing the blue economy might be an example of a wild card. On the one hand, management of coastal areas and marine species might improve. On the other hand, the blue economy might simply become a new label for continued overexploitation that further threatens species and ecosystems. Accounting for a wild card is largely a question of study scope. If uncertainties surrounding a wildcard factor are highly relevant to your study, it would be appropriate to do an uncertainty analysis around the wildcard. However, if focusing on a wildcard may be tangential to the main objectives of your study, you should nevertheless acknowledge the potential of the wildcard to result in unexpected outcomes beyond the scope of your study. The second major category of surprise is the black swan. Unlike wildcards, they do not surprise because their influences are highly uncertain. Once they appear, their influence may be relatively straightforward. Instead, they surprise because they were not imagined or were dismissed as figments of imagination. Black swans reflect a cognitive bias on the part of humans to be overconfident, which means that we systematically underestimate the range of what outcomes are possible. An example of a black swan is the Deepwater Horizon oil spill. A government report and criminal trial found that the company BP made a series of negligent decisions while drilling the Macondo well. BP presumed that an oil spill would be unlikely and that shortcuts taken during the drill would, quote unquote, probably be fine. One might wonder whether a black swan can be accounted for. Approaches for accounting for black swans are similar to approaches that might be used for accounting for the third major category of surprise, the perfect storm. Similar to black swans, perfect storms surprise because they were unimagined or their likelihood was underestimated, and they result when the right conditions occur simultaneously. An example of a perfect storm could be the Fukushima nuclear disaster. Shortly after the disaster occurred, some analysts lamented that Fukushima had safety protocols in place for an earthquake or typical tsunami, but not for both an earthquake and tsunami happening at the same time. Across the categories of black swans and perfect storms that I have touched on here, a common factor underlying surprise is lack of imagination when building scenarios. Some scenario analysts, therefore, suggest that imaginativeness of scenarios can be enhanced by inviting unorthodox people into scenario creation. However, Nobel Prize winning psychologist and economist Daniel Kahneman cautions against trying to be clever when anticipating the future. Cleverness can introduce additional undesired cognitive biases. A way forward is to invite unorthodox perspectives, yet temper potential cognitive biases by applying systematic methods for collecting and synthesizing unorthodox inputs. Theoretical and applied research with cross-impact balances shows that it may be a suitable method for such purposes. In our discussion of research activities that you would undertake during scenario generation and selection, we covered a variety of methods for including diverse participants, accounting for multiple types of uncertainty, combining multiple methods and forms of knowledge, and assuring the diversity and consistency of scenarios. We also touched on combining scenario approaches across different geographical and temporal scales, and approaches to guard against cognitive biases that lead to poor foresight or surprise. Now we turn to processes that happen after you have finished creating your scenarios, starting with scenario communication. The first key consideration is who your audiences are. Naturally, researchers want to communicate their science to as many audiences as possible. However, a one-size-fits-all approach is unlikely to be effective. Messages that work well for media coverage or the general public will lack the detail that decision makers with more technical backgrounds would find informative. Different audiences are likely to find different presentations of your scenarios and their results most instructive. Recall some of the pointers that Hannah made about considerations before embarking on your study. Considerations similar to those you made about your study's purpose will inform how to communicate your findings to different audiences. If you're communicating to the scientific community, communicating to them will be most familiar to you. However, if decision makers are your target audience, consider whether they work in a more technical context, such as the US Environmental Protection Agency, or are more of a high-level decision maker, such as a state legislator. Practitioners in non-governmental organizations might also run the gamut of being more like scientists or more like opinion leaders, so bear in mind the technical background of target audience members. Finally, the science literacy of stakeholders may run a gamut as well. Some stakeholders may not be trained in your area of expertise, but are highly motivated learners and want to understand the technical details of your work. Others may have lower science literacy and be more like interested members of the general public. A natural mode for communicating scenarios is scenario visualization. However, these should be fit for purpose and fit for the target audience as just discussed. Indicators are an example of how findings from scenario studies might be visualized, and there are three main ways that indicators are used. First, there is use for strategic planning. In this example for sea level rise tipping points from Hasnut and colleagues, two metrics are of interest: the year-by-year amount of sea level rise and its anticipated timing. This scientific information is relevant to strategic planning over a multi-decadal time horizon. However, the scientific information alone may not be readily taken up into decisions. Second, there is conceptual use of indicators for learning. Hasnut developed the concept of a dynamic adaptive planning pathway, or DAP, which is visualized like a map used to navigate a mass transit system. Third, there is instrumental usage of indicators directly related to a decision or action. In this sea level rise study, the research team used visualizations to overlay the concept of alternative decision pathways on the time horizon for strategic planning. Using the easily recognizable DAP visuals, the research team demonstrates how the DAP concept can be applied to articulate alternative action plans as well as key temporal milestones by which decisions between alternatives must be made. Throughout the webinar, we have introduced the variety of considerations you should make before and during your scenario study, as well as afterward, when you communicate your findings. However, what evidence do we have that scenario studies have been effective? This is a question for another process that should be done after the scenario study: evaluation. Ultimately, evaluation looks for evidence of learning or having made an impact on a policy decision. However, more empirical research is needed to assess whether outcomes were affected or improved due to scenario products and processes. Some things to keep in mind when you evaluate your own scenario study are that learning can take place at the individual level, such as among study participants. Such learning might be assessed by seeking feedback from participants individually, where they are not privy to the feedback reported from other participants. Learning can also take place at the group level. Such learning might be assessed by seeking feedback from participants in a group setting, such as after an open group discussion. Examples of measures taken as evidence of learning include the level of involvement of participants, such as whether they participated early, often, and interactively, effects on network building amongst participants, and self-reports of issues such as increased trust and understanding of others, or community identification, where participants feel like they are working together as a team to solve a problem rather than working in isolation or as antagonists. Another topic related to evaluation is measuring the success of decision support. Similar to learning, this can be measured at the individual or institutional level. At the individual level, scenarios should ultimately help decision makers feel prepared to be nimble in the unpredictable future rather than paralyzed or dubious. Part of what can help decision makers gain such confidence is to stretch their thinking about what is plausible. In turn, such broadened thinking expands the scope of outcomes that decision makers prepare for, which decreases the likelihood that they will be blindsided by a surprise. Such confidence can be measured through self-reports. Using an example from national UK climate scenarios, Hume and Desai suggested that at an institutional level, a possible measure to evaluate scenario success is whether scenarios offer the prospect that decisions taken in light of them will be robust. In a 2007 paper by Groves and Lempert, they explained that robust decision-making proceeds from the observation that decision makers often manage deep uncertainty by choosing strategies whose good performance is relatively insensitive to poorly characterized uncertainties. Whether a decision would be robust to multiple contingencies can be analyzed through an approach called scenario discovery. Ultimately, however, it is still up to the institution whether they will adopt strategies shown scientifically to be robust. Of course, there is so much more I could tell you, but I think it's time to summarize the tutorial overall.
We've tried to emphasize the essential steps that must be considered during the scenario lifecycle, before, during, and after creation. Scenario creation implies processes, before, during, and after, and products, during and after. Before creating scenarios, it is essential to make choices about the purposes of your exercise and to design methods, data, and participation accordingly. During creation of processes and products, many methods and techniques are already available to combine qualitative and quantitative elements and methods and to bridge or even integrate multiple scales. Finally, it is crucial to consider the life of scenarios after creation. This means to communicate about scenario processes and results, and to evaluate if they effectively reach their goals, in particular regarding learning and decision-making. Beyond the existing guidance and multiplicity of approaches to scenarios, many knowledge gaps remain, in particular to better use scenarios for decision-making and learning. Elsava and colleagues have summarized the future research agenda and compiled open research questions. On this figure, avenues of future research are sorted according to their focus on either scenario processes or products, and according to the main challenge they focus on, namely uncertainty, in the sense of future openness, or complexity, which refers to interrelations within and between environmental and societal systems, as well as to inter- and transdisciplinarity issues. Regarding the focus on the process of scenario development, further research is required on the respective roles of domain expertise, collaboration skill, and workshop facilitation. Further research is also needed regarding communicating scenario findings, how to interpret them as a set, and what their implications are for near-term decisions. Further work is also needed on evaluation study. Continued work in these avenues can lead to a better understanding of scenario creation, communication, and impact. Regarding the focus on scenario products, we need further work to better combine multiple methods and forms of knowledge, to better clarify the application and meaning of concepts like consistency and diversity, and how they might support combining multiple forms of knowledge, and how they might support addressing scaling issues and uncertainties. Continued work in these avenues can lead to an improved use of old and new methods.